Walk through the old streets of Charleston, South Carolina, and look up at the buildings, on the brick walls of the historic houses, the churches, the old warehouses. You will see iron, discs, crosses, stars, small metal shapes bolted flat against the brick, spaced along the walls in neat rows, painted black, some of them beautiful. Tourists photograph them constantly. Guidebooks call them decorative ironwork. Couples buy them as souvenirs. They are not decoration. Each one of those iron shapes is the cap on the end of a long rod. And that rod runs all the way through the building, wall to wall, clamping the brick to the floor beams so the walls cannot fall away from the house. They are stitches. An entire American city is visibly stitched together with iron, in plain sight. And almost nobody who photographs them knows what they are closing. Because on a warm evening in 1886, this city, on the east coast of the United States, in a place where the science of the day said large earthquakes simply did not happen, was hit by an earthquake of roughly magnitude 7. It was felt over more than 2 million square miles. It bent railroad tracks like wire. It made sand and water erupt out of the ground for miles inland. And after nearly 140 years of searching with every tool modern geology has, nobody has ever found the fault that did it. That is the story today. An earthquake in the wrong place, a city that rebuilt itself with iron rods, and a missing fault that scientists are still arguing about right now. Start with the night, because the accounts from Charleston are among the most vivid in American disaster history, and there were tens of thousands of witnesses. August 31st, 1886, about 10 minutes before 10 at night. It is late summer in the Low Country, hot and heavy, and much of the city is outdoors on porches and in doorways trying to catch a breeze. Children are being put to bed. The streets are full of people walking home in the dark. Then comes a sound. Almost everyone who wrote about that night described the sound arriving before the motion, a deep rumble, like a heavy train coming, growing louder from the northwest. And then the ground began to move, and it did not move the way anything in their experience had ever moved. The shaking lasted somewhere under a minute. In that time, the city came apart. Chimneys snapped off at the roof lines all over the peninsula and came down through porches and into the streets, which is how most of the people who died that night died. Brick walls peeled outward and collapsed. Church steeples twisted. Plaster fell in sheets. Whole facades slid into the road. Gas lines broke and fires started in several places, and by pure luck, the fires were contained. Because if Charleston had burned the way San Francisco would burn 20 years later, we would be telling a very different story. When the dust settled, nearly every building in the city was damaged in some way. Something on the order of 2,000 structures were wrecked or badly hurt. Estimates of the dead run from around 60 to over 100, and the survivors did what people do when the ground has betrayed them. They refused to go back inside. For weeks afterward, a large part of the population of Charleston lived outdoors, in parks, in squares, in tents and improvised shelters made from bed sheets and salvaged lumber. Because the aftershocks kept coming, night after night, and no one trusted a roof anymore. Read the accounts, and the detail that repeats is the sound. People describing lying awake in a public square listening for the rumble, learning to tell the difference between a wagon on the cobbles and the earth starting again. Some families stayed outside into the autumn. The aftershocks did not politely fade in a week. Significant ones continued for months. And the region has technically never fully stopped, which we will come back to. And the damage was not confined to the city. In the small towns inland toward the epicenter, buildings came down, rail service stopped, and telegraph lines went dead, which meant that, for a period on that first night, one of the major cities of the American South was simply silent, and the rest of the country had no idea what had happened to it. Now the part that turns a city disaster into a continental event. This earthquake was not felt only in South Carolina. Reports came in from Boston, from Chicago, from Milwaukee and New Orleans, from Cuba, from Bermuda. In total, the shaking was felt across an area estimated at more than 2 million square miles, roughly 2/3 of the United States plus a good piece of the Caribbean. In cities hundreds of miles away, plaster cracked and hanging lamps swung. People in New York felt buildings sway. A single earthquake in coastal South Carolina reached out and touched more of the continent than any American earthquake since the New Madrid sequence, and close to the epicenter, which lay inland, northwest of the city near the town of Somerville. The ground itself did things that people struggled to describe. Railroad tracks buckled, the rails were bent into curves, in some places lifted clear of the ties and twisted into shapes that photographers were sent out to record, because the ground beneath them had spread sideways toward low ground and carried the roadbed with it. Those photographs survive, and they are still used in engineering courses today, because a bent rail is one of the most honest measurements of ground movement anyone has ever accidentally installed. And across the flat coastal plain, water and sand blew out of the earth. Hundreds, thousands of vents, some of them small craters several feet across, spraying wet sand into the air and leaving low white mounds behind when they stopped. Fields were left covered in fans of clean sand, and farmers complained for years afterward that the sand had ruined good ground. We have met this before on this channel, at New Madrid and in the Salt Lake Valley. Loose, wet, sandy ground, shaken hard enough stops behaving like ground and behaves like liquid. And the water forced upward carries sand with it, liquefaction. And in Charleston, it left behind something priceless, a permanent record. Those sand deposits are still in the soil today, and they are the reason we know this was not a one-time freak. Hold that thought, because it is the key to the whole modern story, and we will come back to it. There is one more thing 1886 produced that is easy to overlook. It produced American earthquake science. In the months after the disaster, the United States Geological Survey sent a geologist named Clarence Dutton to investigate, and what he and his colleagues did there had never really been done in this country before. They gathered thousands of reports from across the eastern half of the continent, every account of swinging lamps and cracked plaster and rumbling sounds, and they mapped them. They drew lines connecting places that had felt the same intensity of shaking, rings spreading outward from the epicentral area, and from those rings they worked backward to locate the source and estimate its depth. The resulting government report ran to hundreds of pages and became a landmark, one of the first thorough scientific investigations of an earthquake in the United States. Modern seismology was still decades from having instruments capable of recording events like this properly, so the science began the only way it could, with people writing down what they felt, and one man patiently turning tens of thousands of ordinary observations into a map. First, why did an earthquake happen there at all? And why did it reach Boston? The second question has the cleaner answer, and it is the same physics we covered in the Midwest. Earthquake energy travels through rock, and the kind of rock decides how far. Out west, the crust is young, hot, and shattered by countless faults, so seismic waves get absorbed relatively quickly. The eastern half of North America is the opposite. That crust is ancient, cold, dense, and largely unbroken, and it carries earthquake energy the way a steel rail carries the sound of a distant train. A magnitude 7 in California is a California disaster. A magnitude 7 in the East is a national event, felt by tens of millions of people who never knew they lived anywhere near an earthquake. The first question is much harder, because Charleston is nowhere near a plate boundary. It sits in the middle of the North American plate, more than 1,000 miles from the edge, on a flat coastal plain that had never produced a great earthquake in the entire written history of the colonies. The leading explanation goes back a very long way. Around 200 million years ago, the supercontinent that joined North America to Africa began to tear apart, and the Atlantic Ocean opened in the gap. That tearing left a system of ancient rift structures buried under what is now the American Southeast, a landscape of old broken rock, stretched, faulted, and then buried under thousands of feet of coastal sediment as the sea came and went. Those old faults never disappeared. They simply went quiet, locked into the middle of a plate. And when the modern crust is squeezed, which it constantly is, those ancient weaknesses are the places most likely to slip. It is the same idea as the buried rift under New Madrid, old scars, new stress. But knowing the general answer is not the same as finding the fault. And this is where the story becomes a genuine unsolved case. In California, after a great earthquake, you can go and look at the fault. It broke the surface. You can measure the offset in a fence. In Charleston, in 1886, there was no surface rupture, none. The ground cracked and sand blew out, but no fault trace appeared anywhere. Whatever moved, moved deep, and its motion never reached the surface through thousands of feet of soft coastal sediment sitting on top. So, for nearly 140 years, geologists have been hunting it. They have run seismic surveys that bounce sound waves off the buried rock and read the echoes. They have drilled. They have flown instruments overhead, measuring tiny variations in gravity and magnetism that hint at what lies below. And they have mapped every small earthquake that still occurs in the region, because the region does still shake. There is a persistent cluster of small earthquakes centered near Somerville that has never stopped since 1886. A low, steady crackle of magnitude 2 and 3 events. Occasionally a 4 that rattles windows and makes the local news for an afternoon. Those little quakes are the closest thing anyone has to a live signal from the source, and researchers watch where they cluster the way you would watch smoke to find a fire. They have found candidate structures with names most people have never heard. A buried fault beneath the Woodstock area, structures along the Ashley River, a zone of ancient faulting under the whole neighborhood. And there is still no consensus. Papers published in recent years continue to argue for different candidates in different geometries. Some researchers favor one buried fault. Others favor a network of them. Others argue the source may be even deeper than the mapped structures. The most powerful earthquake ever recorded on the eastern seaboard of the United States, in a country that has mapped its geology exhaustively, came from something we still cannot point at. Now, let us come back to the sand. Because those liquefaction deposits gave scientists a way around the missing fault. If you cannot find the fault, you can still count the earthquakes by digging. Teams have excavated across the South Carolina coastal plain, cutting into the soil to find the buried sand blows from past events, layer beneath layer. Older sand deposits sit under the 1886 layer, and older ones under those. Organic material trapped in and around them can be radiocarbon dated. The result is a record stretching back thousands of years, and it says clearly that 1886 was not unique. Large earthquakes have struck the South Carolina coastal plain repeatedly across the last several thousand years. The published estimates for the recurrence of large Charleston area earthquakes generally fall on the order of several hundred years, commonly cited around 500 years or so between the biggest events, with considerable uncertainty because the record is read from sand rather than from instruments. So the honest summary is this: the fault is missing, the earthquakes are not. Which brings us to the part that matters for the people living there now. And I want to be careful and honest about it, because this channel does not do fake countdowns. Nobody is predicting a Charleston earthquake. The recurrence estimates are long. The last great one was 140 years ago, and in any given year, the probability of a repeat is low. If you live in Charleston, an earthquake is not the thing most likely to disrupt your life. Hurricanes are by an enormous margin, and the city knows it. But the risk is not zero, and 3 things make it worth taking seriously. First, the ground. Modern Charleston has grown across low-lying land, marsh, and in the historic peninsula, a great deal of made ground, fill, poured in over centuries to extend the city out into the water. Fill and marsh are exactly the materials that liquefied in 1886, and there is more of both now than there was then. Second, the buildings. The historic districts everyone loves are built of unreinforced brick, the most vulnerable common material there is, and the wider East Coast has spent most of its history building without earthquakes in mind at all. Modern South Carolina codes do account for seismic risk, but a building code only governs what gets built after it, and Charleston's charm is precisely the part that predates it. Third, the reach. If a magnitude 7 happened there again, the same ancient crust would carry the shaking out across the southeast, to cities and infrastructure that have never once considered the possibility. Ports, bridges, interstates, and a dense band of population from Savannah up through the Carolinas that has grown enormously since the last time this happened. And yet, Charleston did something after 1886 that deserves more credit than it gets. Look back at those iron discs and stars. In the months and years after the earthquake, Property owners across the city drove long iron rods through their damaged buildings, anchored them with plates and washers on both exterior walls, and pulled the brick back together. It was not a building code. There was no state program. It was thousands of individual decisions to reinforce rather than abandon. Engineers today would recognize it instantly as a wall-to-diaphragm anchorage, one of the fundamental retrofits still used on old masonry buildings all over the world. Charleston was doing seismic retrofitting before the phrase existed, and the evidence is bolted to the front of half the historic district. So, 3 futures. The honest way to hold Charleston. Future 1. Overwhelmingly the most likely in any year you pick. Nothing. The small quakes near Somerville keep ticking away below the level anyone notices. The tourists keep photographing the ironwork. The city worries about hurricanes and rising water. Correctly. Most years are this year, and most centuries may be this century. Future 2. The middle path. A moderate earthquake, a magnitude 5, maybe a 5.5, in the Somerville zone. Not a catastrophe. Enough to crack plaster across the low country, bring down old chimneys, close historic buildings for inspection, and remind an entire region that the ground under the southeast is not as quiet as it looks. This is the realistic near-term event. Future 3, the repeat. Another 1886, a magnitude 7 from a fault we still cannot name, under a metropolitan area many times larger than the city that was hit the first time, with soft ground, old brick, and a southeast that would feel it from Atlanta to the Outer Banks. The sand says it has happened before. The sand says it will happen again. The sand does not say when. Here is my honest opinion. After everything the research shows, Charleston is the most quietly honest city in America. It does not hide what happened to it. It wears the repair on the outside, on every wall, in iron, where anyone can see it. Most places bury their disasters. They rebuild smooth and let the memory fade until a channel like this one has to dig the story back up. Charleston bolted the memory to the front of the buildings and then, over 140 years, politely forgot what the bolts were for, until the story became decoration. That is the most human thing in this entire series. We do not lose the warnings, we just stop reading them, and start calling them ornaments. The fault under South Carolina is still missing, the iron is still holding, and the sand under the fields is still keeping the only calendar that matters. So now I want to hear from you. Had you ever heard of the Charleston earthquake before this video? Or did you believe, like most Americans, that big earthquakes only happen out west? Be honest, drop it in the comments. I read everyone, and if you live anywhere in the Southeast, the Carolinas, Georgia, Virginia, Tennessee, tell me. Has anyone ever mentioned earthquake risk to you at a home inspection, an insurance meeting, anywhere? I am genuinely curious what people are told. If this video taught you something school never did, hit the like button. It genuinely helps this channel grow. And subscribe with notifications on, because next, we go to Los Angeles, to a neighborhood of expensive homes with an ocean view that is sliding into the Pacific right now, not in the future, right now. The roads have been cut, the utilities have been cut, the ground is moving feet per year, and it has not stopped. That story is next. The ground beneath America is speaking. Make sure you are listening.